Hello students, today we are looking at neutralization and our learning objective is to understand neutralization and how neutralization can be useful in everyday life. Now before we begin, I want you to ensure that you've got all your equipment with you. Have you got your pen? Have you got your book? Have you got your pencil and your green pen? Again, I would like you to pause the video, gather all of these things, and when you're ready, press play. Alright students, all settled? Now I would like you to write down your learning objective, like I've stated earlier. Again, pause the video and when ready, press play. All right, let's begin. Now, the very first activity we're going to do is our retrieval practice. Remember, retrieval practice is meant to help us to remember things and understand things further based on what we've been learning so far. And obviously, we've been learning about acid and base, and we're going to try and remember some of these things. So what I would like you to do is to actually write down the keyword in your book, okay? And then match it with the meaning. Again, this is going to take you roughly about 5 to 7 minutes. So I would like you to pause the video, take your time to do it. And when you're done, make sure you take your green pen ready to mark and make your corrections. So pause the video and carry out the activity. All right, let's begin. So the first keyword says acid. What is an acid? And actually, an acid is a chemical that has a pH less than 7. So anything from 6 to about 0 or to 1 is actually acidic. Now, the second keyword is alkali. What is an alkali? An alkali is actually a chemical that has a pH more than 7. Okay, so everything that goes from 8 upwards towards 14 is an alkali. Now, the next one is called neutral. What is neutral? Neutral is actually a chemical that has a pH of 7. And an example of neutral is actually water. All right, the next keyword is called corrosive. What does corrosive mean? Now, corrosive means something that attacks and destroys living tissue. This was among some of the things that we actually see when we perform an experiment, or some of the chemicals that we use. Now, the next keyword is called indicator. What does indicator show? Now, an indicator is actually a substance that changes color when added to acidic or alkaline solution. Now, the next keyword is actually insoluble. What does the word insoluble mean? Now, insoluble actually means something that does not dissolve at all. And the next keyword says neutralization. What does neutralization mean? You should be able to guess it. Okay, that is when an acid reacts with a base to make salt and water. Like I said, we're looking at neutralization today, and I'm going to be explaining further about it and how it can be useful in everyday life. So you just have to flow with me. Now, what happens? The question now is, what actually happens when you mix an acid with an alkali? That's the question. And what actually happens is that we make salt. You'll be surprised that we make salt. But this process by which we mix an acid with an alkali is called neutralization. Okay? Neutralization. And what's quite interesting is that there's a color change there. The color change actually tells us that a reaction has taken place, if I'm making sense. So this chemical change is called a reaction, a chemical reaction, like I said. And I've already answered the question for you anyways. How do you know that this chemical reaction has taken place? Is the fact that a color change has happened, okay? We've got red, we've got blue, put together, a reaction took place, and the product, we end up with a green product, if I'm making sense. All right, now, reactions of acid with alkali is what we're going to look at today, okay? Now, whenever we have an alkali solution or compound, and then we react it together with an acid, what happens is we actually make salt. Yes, obviously we've got a table salt that we've got in our house. That's not just the only type of salt we've got, okay? We've got different types of salt. The one that you've got in your house, potassium chloride, is actually one type of salt. There are different types of salts, okay? But remember, to make salt, you have to react alkali with acid, if I'm making sense, okay? And obviously, part of the product is we're going to get water at the end, okay? That will be our product, okay? Now, for example, okay, sodium hydroxide, which is an alkali, reacts with hydrochloric acid, and the product we're going to get is sodium chloride plus water. Now, sodium chloride is actually our salt, if I'm making sense. The reaction between sodium hydroxide and sodium and hydrochloric acid gives us sodium chloride plus water. Water is our waste product, and sodium chloride is actually the salt. So my next extension question for you is, how do you think we can then get the salt completely? And I'm sure you're like, can't we just boil the water? Yes, you can actually boil the water, the sodium chloride solution, because obviously it's going to be in an aquatic condition. And once you can evaporate the water, you're just left with sodium chloride, which is literally salt. Okay, this is your table salt, actually. All right, actually, yeah, sodium chloride, if I'm making sense. All right, let's move on. Now, this is actually an example of how neutralization takes place. This is just to show you a brief demonstration, okay, visual demonstration of how it actually works. Okay, for example, what happens is that 5 centimeter cube of sodium hydroxide is actually put in with a beaker of hydrochloric acid, okay? So they pour it together, a reaction actually takes place, okay? And once that reaction has been completed, okay, the solution becomes neutral. Remember, when something is acidic, it's got a pH less than 7, and when something is alkali, it's got a pH more than 7, okay? So when we put the two together, what happens is it stops, the reaction stops when it becomes neutral. And how do we test this? It's actually by using an indicator, okay? Remember in our last lesson, we talked about universal indicator. The moment the universal indicator shows green, it shows that the solution is not neutral, and neutralization has taken place, if I'm making sense. Now, this is another retrieval question I want you to try and attempt. And the question now is, what happens to the pH of an acid when alkali is added during a neutralization reaction? What happens to the pH of an acid when doing a neutralization reaction? Now, I want you to figure out this answer based on what I've just talked about. What do you think is going to happen to the pH level of an alkali or an acid when neutralization happens? Think about it and then try and answer it in your book. Okay, I believe all of you should say the pH actually goes down to 7, okay? If it's an alkali, the pH goes to 7. If it's acidic, the pH goes to 7, okay? So the solution itself becomes neutral because alkali has reacted with an acid, put together, a reaction happens, and the pH falls to pH 7, if I'm making sense. Now this is actually our success criteria. Hopefully, we're able to understand that neutralization reaction is actually utilized every day in our life, okay? And also, hopefully, you'll be able to secure your knowledge. And obviously, you're meant to be carrying out an experiment, but you're not. That is why I've showed you the procedure. And this is our keywords today: acid, alkali, base, neutralization, and anti-acid. So what I would like you to do is to pause the video and write down these keywords, okay? And when you're ready, press play. All right, let's continue. Now, everyday examples of neutralization. Now, neutralization can be a very, very useful reaction and is used in everyday life. Some problems can be solved actually when we carry out neutralization. Now, this is what you need to remember, okay? It's very important to remember what neutralization is, okay? Neutralization is basically acid reacting with alkali, which pretty much gives us a salt and water. Make sure you remember this equation, okay? If you can pause the video and write it down, that would be brilliant, okay? Anyways, so let's move on. Now, everyday use of neutralization. The number one thing is actually to deal with certain problems that we've got in our body. For example, the plaque acid, okay, on our teeth, okay, can actually be neutralized by using what? Toothpaste, okay? You see that the plaque is actually an acid, and to neutralize it, you have to use something like a toothpaste to actually neutralize it, okay? Heartburn is actually another example of something that do happen in our body, and we neutralize it using antacid tablet. Rennie is actually very popular. You can find it in Tesco and other pharmaceutical stores, okay? The reason why sometimes you have heartburn is the fact that you've got excess acid in your stomach, and to neutralize it, you need a base to actually neutralize it, if I'm making sense. All right, now the last one is actually acid rain polluting lakes. I'm sure you're going to be learning more about acid rain, but imagine an acidic rain actually. To neutralize it, basically what you need is calcium carbonate, which is also a base. If you can try and pause the video and write this down in your book, that would be absolutely amazing. All right, let's continue. Now, What I want you to do now is to have a look at this, okay? I'm going to make some brief explanation. Now, whenever a bee stings you, what's going to happen is that the bee is actually stinging you with something acidic, okay? Something acidic. The venom is stinging you with is acidic. And to neutralize it, what people actually do, or doctors or experts actually do, is to actually pour bicarbonate soda to neutralize that sting, okay? Honestly, what I would say, you probably do not want to experience a bee stinging because it's very, very painful at that moment. But to neutralize that pain, you need a bicarbonate soda, if I'm making sense. And the opposite is actually the wasp sting, okay? If a wasp should sting you, it's actually stinging you with a base, something that is alkali. So to neutralize that alkali, you need a vinegar which is acidic, okay? And that should literally neutralize the pain and stop you from, having more pain, if I'm making sense. So from this one, okay, what I would like you to do is to actually answer some questions based on this, okay? So what I'd like you to do is actually to pause the video and actually answer this question. When you're ready, press play. All right, I believe you've answered the question. Okay, so we're going to talk about it. So the first question says, is a bee sting acidic or base? The answer is acidic. Okay, the sting is acidic. And the next question is asking you, how was the bee sting treated? And was this an acid or base? Remember, it's acidic. To neutralize an acid, you need a base. Okay, so basically, it was treated by adding a base. Okay, if I'm making sense. And I'm going to go back to just have a show you. Now, it was neutralized using a bicarbonate of soda. Now, number two, well, actually, reverse number two. Number three says, what type of reaction is this? Remember, this reaction is called neutralization. If I'm making sense, neutralization. Now, number four said, is a wasp sting acidic or a base? Actually, the sting of a wasp is actually a base, okay? It's an alkali. Basic. The reason why we say basic is because it's also a base, okay? So how was this treated? Was it treated with an acid or a base? Now remember, the sting is a base, meaning it needs to be neutralized using an acid. So it was actually treated by using vinegar, which is acidic, okay? And the reaction of this is also neutralization. If you've gotten this right, make sure you give yourself a mark. If you haven't, make sure you correct your mistakes using your green pen. Now, remember this again, okay? This is so important. That's what I'm reminding you. Neutralization is acid reacting with alkali. I'll give you salt and water as a product, okay? Now, this is actually a reading that I can read on heartburn and base, okay? What I'd like you to do is actually to read it for yourself and think about what it's actually talked about, okay? Again, you can pause the video and actually have a read about where hydrochloric acid is found and how it's neutralized using the antacid tablet, if I'm making sense. So again, you can read it and pause the video. All right, now this is actually one of the last parts of the videos. I want you to think about this question, have a read at it, and actually describe what the graph is showing you. Again, I would like you to pause the video and actually find the connection in it. All right, I believe we're all done. Now let's answer the question. Now the question is asking us to actually describe what the graph shows using your own word. And I believe the first thing you should say is that at the start of the pH of solution 1, okay? Actually, let me read that again, okay? At the start of pH, the solution 1 is 1 and it is so acidic, okay? The line slopes gently downward, so the pH is decreasing slowly. The line on the graph suddenly becomes vertical and the pH of the solution decreases very quickly to pH 7. The milk of the magnesia has neutralized the acid. As you add more milk of magnesia, the pH continues to slowly decrease to pH 12. Students, this is exactly how you get your full 5 marks based on this question alone. So I do hope you've learned quite a lot. Again, make sure you ask questions. If you do not understand anything, send us an email and make sure you've written your note. Make sure you watch this video again and check out some of the other topics that we've talked about on the YouTube channel. And I'll see you later.